I'm about to show you the decomposition of sugar using sulfuric acid. It's an intensely exothermic reaction, generates a lot of dangerous fumes, so we do it in the fume hood, which you see here. So to start, we've got a little bit of water in a Pyrex dish. You can see that's water. I'm going to add a little bit of universal indicator to that. Now, universal indicator sounds like what it is. It's an indicator that will change multiple colors depending on the pH. So often it's provided with a pH scale, a colorimetric pH scale. Generally, reds and yellows are acidic, blues and purples are bases. So keep that in mind. Let me stir the indicator a little bit, make sure it's evenly distributed, and you should see a green color. In fact, I'm going to add a little bit more to that. Now, just to get the color change really good for the actual reaction, I'm going to add sodium hydroxide to that. Sodium hydroxide is a strong base, and so we should see a color change that indicates a very high pH. Again, that'll be purples or blues. So let's add just a few small pieces of the sodium hydroxide. One is probably enough. And you'll see when I start to stir this, you should see a good color change start to occur. And there you go. You can start to see bright purple color show up. Now, bear with me for a minute. I'm going to chop that into smaller pieces so it dissolves a little faster. But once it does, you'll definitely see the purple color take precedent here. Okay, very good. There it is. And let me once again chop up some of that stuff. There we go. So now we've got in there a fairly strong base indicated by the purple. And what I'm going to do is take my sugar, okay, there's just a small sample of sugar, okay, and I'm going to put that in the middle of this weak base, and that's so I'm going to cover it, and it's going to contain these dangerous fumes once they're starting to be generated. Now to that, I'm going to add the sulfuric acid. And pardon me for a minute while I get my safety glasses. Here they are. And let's add the sulfuric acid to this. And I'm going to stir it up, and I'm going to turn on the fume hood. So it might get very loud. The fume hood is negative pressure, so it's drawing air into the fume hood from the lab and then out the roof. So no toxic fumes get into the lab. So I'm going to do this outside because I'm a little nervous about pouring this stuff. It's quite dangerous. Okay. I'm going to add the sulfuric acid to that and stir it up. So let me grab my stirring rod and stir that quickly, and then I'm going to cover it. So right now you're already beginning to see the beginnings of a color change. This stuff was white pure sugar before, and now it is no longer. So I'm going to turn this, put this in the flask so you can see it, and I'm going to cover it up to capture those fumes. And when it starts to go really quickly, I'm going to turn on the fume hood and close the window on it. This is one of those reactions, it's exothermic and takes a little time to reach a threshold temperature, but once it reaches that threshold temperature, the reaction goes very quickly. So in a short couple of seconds, in fact, you'll start to see something happening, and I will turn on the fume hood and close the window so that I can protect myself from those fumes. So just wait for it for a minute, but very soon you should start seeing something happen. Starting to see some bubbling there. That could indicate something's being, aha, watch carefully, and here we go. Wow. Wow. So you should be seeing a lot of evidence of chemical change. Remember the 5 things that indicate that there is evidence of a chemical change. Once this reaction slows down, I'm going to open the fume hood once again, and we'll take a look at those pieces of evidence of a chemical change. Looks like things are slowing down. So I'm going to open this up, and I think they should be obvious. First of all and foremost, when I stir this, you're seeing a fairly significant color change, right? Now we're seeing from the purples, which indicate a base, more of a pink and orange reddish that indicates an acid. we see a new substance being formed. That's pure carbon on the inside of that beaker. It's also extraordinarily hot. I'm going to remove the beaker so you can see that, but it's not going to be pleasant because it's very, very hot. So here I go. There we go. Okay. What you see there is carbon. Okay. We also saw gases evolved, right? Bubbles. So we certainly saw 3 or 4 of those pieces of evidence of a chemical change. This is pure carbon mixed with sulfuric acid. As the reaction shows, it would result in carbon. There's an awful lot of gas space in there. Let me hold that up so you can see what that looks like. An awful lot of gas space in that product. Oh, thanks for attending my TED Talk.